Okay, hello Professor, I'm Kenny Kamara. Today I'm going to be doing lab number 4, question number 3, and so let's get started. So I hope you don't mind I set up the frame of the matrix because I recorded this before and it took me quite a long time to actually draw it. But so to start off this problem, we have our initial population up here. We know there are 80,000 infected, which means that there are initially 320,000 people who are not infected. And we know that there are initially 80,000 people who are infected. I'm going to put N for never infected, I for infected. And this is a 4x1 because there are two other hidden things right here. But there are people that have recovered. Initially, there are 0 people who have recovered. And there are people that have died. Initially, there are also 0 who have died. And so these are initial numbers. This is actually our X naught matrix. And from these probabilities up here, we see that 3% will die of the people who have been infected. Of the people who have never been infected, 20% will become infected, which means 80% will remain uninfected. And of course, up here, 97% people will recover. And so I'm going to set this up for here. So never infected, infected, recovered, and then deceased, never infected, infected, recovered, deceased. I'm going to fill this out with the probabilities from above, which means that of the people who have never been infected, 80% will remain never infected, while 20% will become infected. And of course, people who have never infected cannot recover, nor will they die. Of the people who are infected, they can never become uninfected again. They will not stay infected. And 90% of them, 97% of them will recover, while 3% of them will die. Of the people who have recovered, they can never become uninfected again. They can never become infected again because they're immune. However, they can remain infected. It's the only thing they can be because they can also not die in this situation. And of the people who have died, they can only stay dead. They cannot resurrect in any way. And so, using these matrices, we can do some math Markov chains using this equation of x sub n times p to the n times x naught. So we will actually be doing this since this is 4 years in the future, right here. We will be doing x4, oops, it should actually be an equal signs right here, my bad. P to the 4th times x naught. And this equation, this one right here, this is P, this matrix, and this is x naught as I labeled earlier. So this will simply be to the power of 4, and then multiply that by this. And doing that in a calculator will get us a matrix that has, or that looks like this: 1, 3, 1, 0, 7, 2, 3, 2, 7, 6, 8, 2, 2, 9, 0, 7, 5.2, and 7084.8. This is the matrix solving this will get us, which means that 131,072 people after 4 years will have remained never infected throughout the time. 32,768 will be currently infected in the 4th year. 229,075 people will have recovered and become immune, whilst 70,085 people will have died in the 4th year. And that is the end. Thank you.